Okay, so I went to LeetCode again and then try to find another problem, and then I try to use Golang here. Yep. So the problem is called counting bits. Given an integer n, return an array ans of length n plus 1 such that for each I, 0 is less than or equal to I less than or equal to n. Ans I is the number of ones in the binary representation of I. Okay. Example is input n is equal to 2. 0, output is 0, 1, 1. Okay. Explanation is 0. Okay, so basically, I think what he means here is you're converting the decimal to a binary representation, and then from after you get the binary representation, you'll count the number of ones in the bits, right? So if you're not familiar with binary representation number, I would suggest you go look it up. What's a binary representation of a number means. Um, in general, the decimal value that what you have, like for example, 0, 1, 2, these are all decimal values, like this base 10. Base 10 is like the counting numbers where the numbers are from 0 to 9. And if you're converting it to base 2, your number representation is only 0 and 1. Yeah. Um, 0 to 9. Yeah. Okay. So for example, 0, when you convert it to binary representation, it becomes 0. 1 is still 1. 2 is 1, 0. Um, 1, 0 is the binary representation. So basically, you kind of have to mod by 2, the number, and then you put and you divide it. So you kind of result in 0 as a, and then 1, because the modulation is 0, and then you have 1 in the, as a, when you divide the number. So I would suggest you go look it up um, how to convert decimal to binary. Yeah, yeah. So basically, you write down the decimal number, divide the number 2, write the result, and then you divide it by 2 again. Write down the remainder. That's the manual way of converting it. If you're not familiar with it, 0 because there's no 1 here, so it's 0. 1, there's 1 1, so you have 1. 1 0, you have 1 1, so it's 1. Similarly, if you go here, you notice there's 2 here. It's because from the binary representation of 3 is 1 1. So if you count the number of ones, you get 2 here. Same as this. 1 0 1 is 2. Um, yeah. So if you're not familiar with how to convert it, in general, you just have to divide and then you mod it. So that's how you normally get the binary representation of a number. Okay, right. So I guess, can you do it in linear time, single pass? Let me check. I think you can do a lookup here where you calculate the value first, and then, okay, so this value comes from the fact that 2 mod 2 is 0. And then when you divide it, you got the 1, right? Then you can simply look up the pre-calculated value here, which is 1. So when you append, then you got a 1 0. Like for 3, for example, you mod 3 by 2, you get a 1. And then you divide 3 by 2, you get a 1. So when you look at uh, 1, it's 1, and then 1 and 1. How about 4? 4 initially, when you divide 4 by 2 is 0, and when you mod, and then when you divide it by 2, you get a 2. 2 is 1 0. So what happens here is you kind of appending the previous value and the divided value and the mod value here, right? Yeah. So I guess we need the okay, we need the list to, because this is where our result is. How do you make a list? Okay, this is how you make a dynamic list in Golang. So let's create a list where the output is n plus 1, right? Yeah, because based on this, the length is n plus 1. Okay, so now what we're gonna do is, okay, the first two values already calculated. So A0 will be 0, A1 will be 1, obviously. And only on the third part we start, so we have to do a for loop here. For I, starting from 2, I is less than, I guess, n plus 1, and then I plus plus. Okay. So to represent the, so yeah, our algorithm a while ago is we need to do a mod, on the on I. So I mod 2, and then you add it by I divided by 2, but we have to look it up from the array because we pre-calculated it. Then A is equal to A I. Yeah, I guess will this work if you do a count? Um, if you look at it, it's kind of like you're counting in and then you're adding all the ones here, right? Because eventually if this is 1 and this is 1, then you got a 2. So basically you're already counting on the fly. So you could technically do this in linear time by just simply using this as the base. So let's see if this is gonna work. Return. Okay, it did work. Index out of range. I length count bits. A case where if n is equal to 0. Yeah, I know, n is equal to 1. Like you started with the, oh, it's 0. Yeah. If n is equal to 1, I guess. I'm not sure. 0. Yeah. Then the output would be a return int with 0. This is how you do this. I think you have to make it like this. Let's see. Now I think you can just do something like this with the one value. Okay, there you go. It works. I think I could do this in Golang, I guess. Just remove this and then return. Try again. Syntax error. Return. Those braces. Later. Okay, it worked, but it's slower. I guess it's machine dependent. Yeah, okay, now we got 100%. This is what we want. Okay. So yeah, that's it. We solve it within maybe 5 to 10 minutes. That's it. That's because we got 100%. Yeah, thank you for watching. I hope you liked the video. Please subscribe if you like it. I'm still working on making this better, but um, I hope you like the solution.